Greetings to everyone. I am Sim Hui Lin, a student under the supervision of Dr. Alvin. I will be presented the undergraduate project which I have done on the comparison between IFSAR data and unmanned aerial vehicle imagery for the forest canopy height mapping. A little bit about the introduction. Forest application require reliable 3D forest metric estimation. Both the horizontal and the vertical vegetation component estimation act as significant ecological parameters as they correspond to the volume of timber, biomass, and also the carbon stock. Here, the horizontal vegetation components refers to the forest canopy, the diameter, and also the density of the vegetation, while the vertical vegetation is the forest canopy height. However, to gather these information through the fieldwork requires a large amount of labor, time, and cost. Therefore, obtaining the measurements remotely would bring advantages to the work. Through the years, the advance in remote sensing techniques has brought the technology into many fields, especially in the forest management or the forestry. Among all the techniques, light detection and ranging, which is the LiDAR, and also the interferometric synthetic aperture radar, which also called as IFSAR, are very common to use in collecting data. Both of the techniques can generate high-resolution surface which provide more detailed measurement, for example, canopy height, cover, and density. However, according to the research done by Doman in 2004, he compared both the methods and he found that IFSAR is more cost-effective. Apart from LiDAR and IFSAR, the appearance of the unmanned aerial vehicle UAV technology has brought a new approach to the data acquisitions. Those small autonomous machines can obtain high-resolution image and 3D data in a reasonable cost. Researchers are starting to use UAV technology in the forest estimation, but there are still many research based on the spaceborne LiDAR. As the cost for using LiDAR is high compared to IFSAR and UAV, which obtain the data in a reasonable cost, in this project we will compare which IFSAR or UAV data can get better in generate forest canopy height. So the aim for the project is to compare the canopy height generated from UAV imagery by different flying height, which is 150 meters and also 300 meters, and also the IFSAR data. There are several objectives to achieve in this project. The first one is to identify the previous method that have been used to produce the canopy height. The second one is to generate canopy height from UAV imagery of different flying height. And then the third one is to generate canopy height from IFSAR data. And the last one is to compare and analysis all the canopy height. For the scope of this project, first the study area. The study area is located at Parcel 6 hectare plot, which is at the Parcel Forest Reserve. And to acquire the data, we use the RGB sensor which attach on the UAV and also the IFSAR data. And to process the images, we use ArcGIS photoscan software to process those images, and then we proceed to the ArcMap to generate the canopy height. And the final outcome of this project will be the comparison between the canopy height generated and find out which is the better to get the canopy height. For the part of methodology, a little bit explain about the study area. This research was carried out at Parcel 6 hectare plot, which is an ecological research site for the Parcel Forest Reserve. So the Parcel Forest Reserve is located in the district of Simpang Pertang in Negeri Sembilan, which around the center of the Peninsula Malaysia. Parcel Forest Reserve is a lowland dipterocarp forest, which have the total areas of about 2,450 hectares. As in the image, you can see that this is the study area that around in the Parcel 6 hectare plot, and the image is taken around the triangle aluminium tower there. For the analysis overview, we illustrate the methodology, analysis, and also the output in this flowchart. So first, we will get the different flight altitude UAV images and also the IFSAR data. And then we will proceed to generate the DSM, which is the digital surface model. And after getting the DSM, we will work together with the DTM to get the canopy height model. After we get the canopy height model, we will extract the tree height based on the canopy height model. And then we will do a comparison between the tree height based on the other research to find out the exact tree height of the study area. Next, we will see the step to produce digital surface model using ArcGIS for the scan software. After importing all the images into the software, we can create a batch process at the workflow. And then we can add in the align photos and also the build dense cloud jobs into the batch process. After adding these two, we will proceed to adding the build DEM job. So in this part, we have to check with the source data and projection and also resolution. The source data must be dense cloud, and the projection that we will use which is the WGS84, and also the resolution 0.1. And then we will proceed to adding the build automosec job. In this part also, we have to check with the resolution, projection, and also the surface. Same as the previous one, the resolution and the projection, which is 0.1 and WGS84. And then the surface, we were using the DEM surface. After adding all these 4 jobs, we will click OK and run the process. And at the end, we will get a product of a digital surface model and also automosec. So after we generate the DSM, we can proceed to the next step, which is to produce this canopy height using UpMap. So we can find out the canopy height model by minus or subtract the DTM from the DSM. So we will use the raster calculator from the software. You can see that here we minus the DSM and we minus the DTM from the DSM, and we will get the output raster as a different map, which is this one as the photo. And in this part, we will find out that there will be some value which have negative values. So we have to remove all the negative values to find which is the canopy height. So in this case, we have to use the conditional tools. So we will put the equation as con the layers that we want, which is greater than 0, as the height is greater than 0, and return to the layers itself. At the end, we will get out some products like this, which is the canopy height model, as shows the height of different pixels in the map. And then we have to identify the canopy height. So I have selected a number of 50 trees, and we have to record down all the height according to the different data set. So in the table, you can see that there's UAV 150 meter, UAV 300 meter, and also IFSAR. You can see that in the first tree, it record 24 meters in the UAV 150 meters data. However, it only have 5 meters in 300 meters UAV flying height. And for the IFSAR data, the first tree get around 10 meters high. So we will create a graph from this table, from this result, and then we will compare the result that we get. So here is the graph that we have created according to the table and according to the record, all the 50 trees. We can see that the blue color is the UAV with the flying height of 150 meters, and the orange color is the UAV flight with the 300 meters, and the gray color is for the IFSAR data. So now we compare our result with other researchers' result. Kocherman and Okuda state that the Pasir Forest Reserve is a lowland dipterocarp forest, and it consists a high proportion of Dipterocarpaceae family. And then Kocherman also stated that the Dipterocarpaceae family is best in categorize the upper canopy and the emergent layers of the forest in Malaysia. And then the Apana stated that those forest emergent species are reaching about 30 to 70 meters of height. So from here, it can be said that the canopy height should be around 30 meters and above. And then the Kocherman also found out that the layers of the rainforest are assigned into 5 different classes according to their diameter at breast height, which is the dBH. So he stated that the dBH less than 2 cm, the tree height will less than 2 meters. For the dBH less than 10 cm, their tree height is less than 10 meters, and so on. For the less than 30 cm dBH, the tree height is less than 20 meters, and for the dBH less than 60 cm, the tree height is around 30 meters, and for the dBH which greater than the 60 cm, the tree height can reach about the 30 meters to 50 meters. And at the Pasir Forest Reserve, the Dipterocarpaceae family was the most abundant family for trees, which having the dBH larger than 10 centimeters, said by the Kocherman. So this can be explained that the tree height of this study area should be above 10 meters, because the dBH is larger than 10 centimeters. From the graph, it shows that the canopy height extract from the IFSAR data are not that reliable because it only shows that a range from 0 to 20 meters. So the last one, the Kocherman and Apana also state that the Dipterocarpaceae family, which mostly in the emergent layer, have the height above 30 meters. So by comparing the canopy height extract from the UAV 150 meters and also the 300 meters flying height, the data obtained from the 150 meters flying altitude are more likely to derive the canopy height, which is more closer to the actual scene. The canopy height from 300 meters UAV flying height is range about from 4 meters to 29 meters, while for the 150 meters UAV flight altitude, the range of the tree canopy height is from 16 meters to 46 meters, which is more closer and more suited for all the statement above. For the future research and also some of the recommendations, we recommend that you can compare with different sensors attached on UAV. For this research, we only use the RGB sensor. There are many other sensors, for example, like near-infrared sensors and also multispectral sensor. And then the next one is process images from different software. There is another proprietary software such as Pix4D, and also open source software such as MicMap and Bounder. For this research, I use only the Agrisoft PhotoScan. So with other software, we can compare the time processing and also the performance, as different software uses different algorithms. So in conclusion, the results of this research suggested that the 150 meters UAV flying height is suitable to use in forest measurement or measure the canopy height. The data from 150 meters UAV flying height is more accurate and closer to the actual scenario compared to the data from 300 UAV flying altitude and the IFSAR data. As forest application requires reliable and accurate estimation of 3D forest metrics, it is suggested that to adopt more in the methods to use more of this UAV technology in the forest community. That's all for my presentations. Thanks for listening, and I really appreciate that you took time to listening to my presentations.